Hello everyone, welcome to SJCE content. This is Dr.L.JETHRUTH EMELDA Mary, Assistant Professor in Mathematics, St.Joseph College of Arts and Science, Autonomous, Cuddalore, Tamil Nadu. In this video lecture, I am going to explain from the topic Calculus for first BSc Mathematics. Here I have taken the topic Curvature and Radius of Curvature. So there are three different formulas to find radius of curvature. One is the radius of curvature using Cartesian coordinate, another one is using polar coordinate, the last one is using parametric form. Here I have taken the equations using parametric form. The first question is prove that the radius of curvature at any point of the cycloid x is equal to a into theta plus sin theta and y is equal to a into 1 minus cos theta is 4a cos theta by 2. So x and y are defined in terms of parametric form. I must prove the result that the radius of curvature rho is 4a cos theta by 2. So x is defined in terms of theta, so I just differentiate x and y with respect to theta here, so that we'll get x dash is equal to a into differential of theta is 1 and differential of sin theta is cos theta, so x dash equal to a into 1 plus cos theta. Similarly, we differentiate x dash with respect to theta again, you'll be getting x double dash that is equal to minus a sin theta. Then we'll find differential of y with respect to theta, that is dy by d theta equal to y dash that is equal to a sin theta. And when I differentiate again with respect to theta, this y dash will get d squared y by d theta squared, that is y double dash equal to a cos theta. Because differential of sin is cos, so we have a cos theta. We know that the radius of curvature using parametric form is x dash square plus y dash square whole power 3 by 2 divided by x dash y double dash minus x double dash into y dash. Just substitute all these values in these expressions and simplify. We'll be getting 2a root 2 into 1 plus cos theta whole power 1 by 2. That is 1 plus cos theta is rewritten as cos square theta by 2. Therefore, finally we'll get 4a cos theta by 2. So this is what we have to prove. Hence the problem is over. Next we'll move on to the another problem. Find rho at the point t for the given curve x equal to a into cos t plus t sin t and y is equal to a sin t minus t cos t. Here also you are going to use the parametric representation to find the radius of curvature. X is defined in terms of t and y is defined in terms of t. So let us find out x dash and x double dash, similarly y dash and y double dash. So to find x dash, just we differentiate x with respect to t. So we will be having a constant, keep a constant as it is. Differential of cos t is minus sin t, and just apply UV formula for t sin t, we'll get sin t plus t cos t. Just simplify this, plus sin t minus sin t is getting cancelled. We have x dash equal to a t cos t. Differentiate x dash with respect to t again, we'll get x double dash equal to a. Using UV formula for t cos t, we'll have cos t minus t sin t. Then we'll find y dash. Y dash is nothing but dy by dt, that is a. Differential of sin is cos, and differential of t cos t, using UV formula we have cos t minus t sin t. Here cos t minus cos t cancel. Finally we have minus a t sin t. Similarly, we differentiate y dash with respect to t, we will be getting y double dash. Y double dash equal to a into sin t plus t cos t using UV formula. Then just substitute all these values in the equation of radius of curvature, namely rho is equal to x dash square plus y dash square whole power 3 by 2 by x dash y double dash minus x double dash y dash. Substituting all these values in these expressions and just simplify this, finally we get a square t square whole power 3 by 2 into cos square plus sin square t whole power 3 by 2, this become 1. Similarly, the denominator we have a square t square of cos square t plus sin square t, this is also 1. So what we have is a square t square whole power 3 by 2, cancelling this a t whole power 3 by 2, so 2 cancel, we have a t whole power 3 divided by a t square, or you can write this is a t square whole power 3 by 2 minus 1 also. So that gives 8 square t square whole power 1 by 2. Square root of a square t square whole power is nothing but just a t. So we find that the radius of curvature is rho is equal to a t. Okay. Now we'll move on to the another problem. Show that the evolute of the cycloid x equal to a into theta minus sin t and y is equal to a into 1 minus cos t is another cycloid. So we are given a cycloid, the equation of cycloid in terms of theta. We have to prove that the evolutes of the cycloid is again a cycloid. Okay, we know that the equation of cycloid already. So just find out the first order derivative of x as well as first order derivative of y with respect to theta. So we have dx by d theta is equal to a into 1 minus cos theta. Similarly, dy by d theta is a sin theta. Okay, then what is y1? Y1 is nothing but dy by dx. So we'll write dy by dx as dy by d theta into d theta by dx. So dy, just substitute dy by d theta value, and the reciprocal of dx by d theta is d theta by dx. Just substitute everything here. We'll get sin theta by 1 minus cos theta. That is our y1. Next we'll find y2. y2 is equal to the second order derivative d squared y by dx squared. Since dy by dx is in terms of theta, so I must express this formula like this. So this d squared y by dx squared can be written as d by d theta of dy by dx into d theta by dx. Let us differentiate this dy by dx value with respect to theta and multiply that value by the reciprocal of dx by d theta. Okay, then just differentiate it by using u by v formula. We have this expression, and just simplify. Finally we get y2 is equal to minus 1 by a into 1 minus cos theta the whole square. Then so curvature. So you are going to prove the curvature of the cycloid is again a cycloid. For that, just curvature is nothing but the center of curvature. The formula is x equal to x minus capital X equal to small x minus y1 into 1 plus y1 squared by y2. So this is your y1 is first order derivative, y2 second order derivative, and x is the given coordinate. So replace the value of x by a into theta minus sin t, and y1 is this a sin t by 1 minus cos theta. Then y1 squared is 1 plus sin theta by 1 minus cos theta the whole square, divided by y2 is minus 1 by a 1 minus cos theta the whole square. Again we'll just simplify. We'll get finally a theta minus a sin theta plus a sin theta into 1 by cos theta the whole thing into 2 minus 2 cos theta. Again finally after simplification we'll get x equal to a into theta plus sin theta. So this is center of curvature for x coordinate. Then we'll find similarly y coordinate. Capital Y is equal to small y plus 1 plus y1 squared by y2. The value of y is a into 1 minus cos theta, whereas y1 is sin theta by 1 minus cos theta the whole square. Cos theta, just square it, we have the whole square, divided by y2 is minus 1 by a into 1 minus cos theta. Next, just simplify. We have this as minus of a into 1 minus cos theta. This is where curvature of center of curvature of y coordinate. So we found that the curvature for the center of curvature of x coordinate is a into theta plus sin theta, and y is minus a into 1 minus cos theta. So these two curvature represents again a cycloid. Hence we prove the result. The next one is find the evolute of the ellipse x squared by a squared plus y squared by b squared equal to 1 at any point on the ellipse. So the equation of ellipse is given. Just we write the parametric form of the polar coordinates of equation of ellipse, and we find out the equation of evolute of the ellipse. So already we know that equation of that is the parametric representation of ellipse is x equal to a cos theta, y equal to b sin theta. These are the parametric representation of ellipse. So dx by d theta is what? Minus a sin theta. Dy by d theta is just b cos theta. Find out y1 value first. Y1 is what is that? Dy by d theta into d theta by dx. Here we have b squared by a squared into minus a cos theta by b sin theta. So by simplify we have y1 is minus b by a cot theta, b by a into cot theta. Similarly we find y2 by using the formula d by d theta of dy by dx into d theta by dx. We'll get this as y2 is equal to minus b by a squared into cosecant cube theta. So again we use the center of curvature x equal to capital X equal to small x minus y1 into 1 plus y1 squared by divided by y2. Substitute all these values here and simplify. We'll get the answer is a square minus b square cos cube theta by a. This is the center of curvature in x coordinate. Similarly for y coordinate we have capital Y equal to y plus 1 plus y1 squared by y2. Substituting these values here and simplifying, we'll get this as y is equal to minus b a sin cube theta by b. Now we know sin theta value and cos theta value from the center of curvature. Find out that values here. we have minus by a square minus b square whole power 1 by 3. Cos theta is ax by a square minus b square whole power 1 by 3. So just square this. Squaring, adding these two equations, will get sin square plus cos squared equal to we'll get this is what, ax by a square minus b square whole power 2 by 3 plus minus by a square minus b square whole power 2 by 3, that is equal to sin square plus cos square, that is always 1. So we have that is equal to 1. Now a minus b square whole power 2 by 3, in the denominator we have a minus b square whole power 2 by 3. Take it, just when you take the term to the right hand side, we have ax whole power 2 by 3 plus by whole power 2 by 3 equal to a square minus b square whole power 2 by 3. Okay. Now we have another problem, the last problem. Prove that the PR equation of the cardioid r is equal to a into 1 minus cos theta is rho squared equal to r cube by 2a. The equation of cardioid we already know, r is a into 1 minus cos theta. We are going to prove the PR equation, the pedal equation. So for that, just let us find out the first order derivative of the given equation r and second order derivative of r. For first order derivative, we have dr by d theta is a sin theta. When I differentiate again with respect to theta, we will get d squared r by d theta square, that is a cos theta. So the equation of pedal or the PR equation is 1 by rho squared equal to 1 by r squared plus 1 by r power 4 into dr by d theta the whole square. So substitute this dr by d theta value here and simplify. You will get rho squared equal to r power 4 by r square plus a square sin square theta, replacing r value by a into 1 minus cos theta the whole square, 1 minus cos theta the whole square, and expanding the term, we get the expression like this in the denominator. So what is that? R power 4 by a square cos squared a square sin squared become 1. So a square plus a square 2a square minus 2a square cos theta. By taking again 2a squared out, we'll get 1 minus cos theta. So that 1 minus cos theta, again by using the equation of cardioid, from that we find 1 minus cos theta is r by a. So replace that value here. We have rho squared equal to r power 3 by 2a, r power 3 by 2a. So the result is proved. Thank you for watching this video.